Good morning, everyone.
Sir,
Is my screen visible?
Yes, sir.
Is it now visible?
Yes, sir.
Sir,
Okay. Wait for 1 minute. Okay, shall we begin? Shall we begin?
Yes, sir.
Okay. So, we will see some more examples. So, yesterday we saw that Rn, the dual space of Rn is Rn when we take uh, the norm as 2 norm, okay, the usual norm. So there is an exercise. So here is an exercise for you. So you saw that Rn dash is isomorphically isometric or isometrically isomorphic to Rn. So when we were taking 2 norm. So what happened when we take 1 norm or any p norm where p lies between 1 to infinity? Okay. So find dual of find R and dash when with respect to norm find Rn taking norms this and this. Okay. So this is an exercise. So one hint is there. So yesterday you saw that when we were taking 2 norm, when we were taking this norm linear space, its dual was, in this case, dual is isometrically isomorphic to Rn itself. Correct? There is a relation. So here in Rn it was 2 norm, here also it was 2 norm. So this means it satisfies some property 1 by 2 plus 1 by 2 is 1. So see what will happen. Okay. So you will get some hint from today's example. So I'll start from L1. The dual space of L1 is L infinity. So you all know what L1 is, you all know what L infinity is. So can anyone recall? Recall Neetu Rawat? Hello?
yes, sir.
Could you please recall this? What is L1 and what is L infinity?
Uh, L1 is a set of convergent sequence with a summation over 1 to n xi always finite.
Uh, so what did you say? So element of L1 are convergent sequences.
Yes, sir.
That's what you. Okay, and what is the norm?
Norm is summation over
Hmm.
1 uh, 1 to infinity xi
What?
mod of xi की power p and whole to the power 1 upon p.
Okay, okay. Could you repeat?
Summation over 1 to infinity
Okay.
mod xi
Mod.
xi
Okay.
raised to the power p
Okay.
whole to the power 1 upon p.
Okay, but there is one problem. So this is the definition of P norm. So here we are taking P equal to 1.
अच्छा,
Do you
1
see
norms.
this? Huh?
Okay, so we can take 1 p in place of p.
We will take 1. Okay, in place of P. Okay, that's good. So let's start. So you correctly said that element of X L1R. So X will be some. It will be a sequence. So elements are X1. Elements of the sequence are X1, X2, Xn, such that this happens summation mod Xi. This is finite. I1 to infinity. Okay, correct. That's good. Uh, so uh, we have discussed this earlier, and we note here this L1 has a basis. Note that EI. You all know what is EI. I'll write it again. EI. This constitutes a basis. A basis. Its name is Sauder's basis. Okay, we call it Sauder basis for L1. Where what is EI? Where EI is del ik. So this sequence del ik means this is a sequence where at the ith place it is 1, otherwise it is 0. Say it's 0, 0, 0, then 1, this is ith place, then again 0, 0. So this means what is E1? E1 is 1, 0, 0, and so on. What is E2? E2 is 0, then at second place it is 1, then 0, 0. Correct? So and so on. So since this is a basis, so every element of L1, so any element of L1 can be written uniquely, or X in L1 can be represented uniquely in this form. 1 to infinity. So xk, okay, xi. Okay. So where x equal to this sequence x1, x2, x3, and so on. So if X is in this form, okay, X is this sequence, then it can be represented uniquely in this summation xi ei. Correct? So, so our aim is to prove the dual space of L1 is L infinity. So what we do, so if we take a linear bounded linear functional in L1, okay, of so bounded linear functional means a linear operator from L1 to K, correct? So what we will prove is, so we will take a linear functional from L1 and uh, we will find a element in L infinity, okay, and vice versa. We will take a point in L infinity or an element in L infinity, and we will produce corresponding linear functional in L1, and we will see what is the norms in both sides. Okay, so consider linear functional in L1, then for every x in L1, so x is represented in this form. So for x in L1, it can be written as fx equal to summation I 1 to infinity xi f of ei. Correct? So here again we know x is x1, x2, xn. This is the sequence, and x belongs to L1. So it's okay. So far it's okay.
Yes, sir.
Okay. So you all know for each I, we all know that for each I in positive integer, the norm, the one norm of ei. What is one norm of ei? Which is
One.
one. बहुत बढ़िया. This is one. And now let's see whether so clearly this f is so this f is linear. We know this. We can prove in fact this f is linear. So it is linear functional. Oh, so I did a mistake. So I said it, I said the right thing, but I wrote something wrong. So here f is in dual space of L1. So L1 dash. Okay. So this means since f belongs to L1 dash means this is linear and it is bounded. Correct? So let's see what is f of ei. So by definition of bounded linear functional, this is nothing but norm f, norm ei. Correct? But you know norm of ei is 1, this is norm f, and you know f is bounded, so this is fine. Correct? Now take supremum on both sides. This implies supremum over ei. So I in z plus mod of f of ei. This is less than equal to norm f. So you see what we are going, what we are doing. So we are trying to prove that norm in L1 dash, norm in L1 dash. So here we took an element from L1 dash, and we are now finding a relation Okay, we are finding the norm of f. Okay, so so far we get this relation. So if you remember what is the norm in L infinity, can anyone recall what is the norm in L infinity?
Supremum of norm xn less than
हाँ,
सुप नॉर्म होती है सर
सुप नॉर्म होती है ना. देखो अभी हमारे पास कुछ आया है सुप नॉर्म. सो हमने हमने एक एक इनइक्वालिटी प्रूव करी कि सुप नॉर्म ऑफ एफ ई आई इज लेस देन इक्वल टू नॉर्म ऑफ एफ. अगर हम एक और इनइक्वालिटी प्रूव कर दें, नॉर्म ऑफ एफ इज लेस देन इक्वल टू सुप ऑफ एफ ई आई, तो दोनों इक्वल हो जाएंगे. दिख रहा है आपको? ठीक है. ओके, सो far we got this thing. So if we take u, an element in L infinity u, so L infinity means these are convergent sequences, means summation, not convergent sequences, what should I say, the summable sequences. Okay, so if you take u equal to f of e1, f of e2 and so on. Okay, so this is a sequence, and this is in L infinity. So this means from star what we are getting. So what is norm u infinity? Can anyone tell what is norm u infinity? If you have a sequence in L infinity, if you have a point in L infinity, fe1, fe2 and so on, take an element in L infinity. So what is its norm?
the
This is
supremum
nothing
of
but sup norm.
mod
This
f
is,
ei.
this is sup norm. Correct? And from start this is nothing but less than normal. Okay? Now, so here what we did, we take an element from the dual of element and we find an element in L infinity with this relation. Okay, now to converse. So on the other hand, we do converse thing. Now take elements from L infinity. For every p, call it beta 1, beta 2, this in L infinity. So obtain a bounded linear function at all n1. Okay. So for every we can obtain a bounded linear functional, we can obtain a g L1 prime. So how do we do this? Let's do. So given this b, we have to define g in L1 prime. How do we define? In fact, this g can be defined. Define g on L1 by gx equal to summation I runs from 1 to infinity xl beta l, where x is x1, x2, and this is in L1. Okay. So this G is linear. This is clearly linear. You can prove this. G is linear. This is easy to show. 1 minute. Okay. Now we have to prove that. So G is linear. Oh, and now we have to prove that G is bounded. So since I wrote that we can obtain G in L1 prime. So elements in an L1 prime are bounded linear functional. So it is linear. We have to show that it is bounded. So for bounded, what we do, we consider mod of Gx and use triangle inequality. This is nothing but I1 to infinity mod xi. So this is I, okay? Xi beta I. Okay, so far it's okay. So if we use uh, subnorm on B, so this B belongs to L infinity. So what we get, this is less than equal to sub I mod Bi. This is subnorm of B, summation I runs 1 to infinity mod Xi. So you know this part, this is P infinity, and second part, this is 1. Correct? Norm of 1 norm of X. Correct? So this B is in L infinity. So you know this thing is finite. So this implies mod Gx is less than equal to some constant norm 1. Okay? This implies G is
Bounded.
bounded, or you can say G belongs to L1 prime. So we have shown that there exists, so for every B there exists a G in L1 prime. Okay? Now what we saw that the norm of F that we considered above, so here we can define this F. Now we saw that norm of F is same as norm in L infinity, the subnorm. Okay, the norm of F is the norm on the subnorm. Okay, so this is we now show. So now we claim that norm of F is the norm on L infinity. So one part we have already shown that this is less than equal to this. If we prove other inequality, what is that other inequality? That is norm of F is less than equal to subnorm. Okay, then both are equal. So let's do that. So what is mod of fx? So by definition, so what was fx? Fx was summation xi. So here was my fx. So this is summation xi fi. Summation I 1 to infinity xi f of ei. Correct? So you same thing that we did here. So this is less than equal to sub I in z plus mod of fi and summation I1 to infinity mod of xi. So this part is nothing but f of e1, f of e2, and so on, subnorm and one norm. Do you see this?
Yes, sir.
Okay. Now supremum over all of x. So these EI are fixed, so you have fixed basis. So take supremum both sides. So first you should know what is norm of f. Norm of f is supremum of all mod f x such that x in x and norm x equal to 1. Correct? This is one definition of norm of f. So taking supremum over all x, supremum over all x of norm 1. So what you get, take supremum both sides. So this part is, it will remain same, and norm of x is, so since this is of norm 1, so this part is 1. So what we get is supremum over mod of fx, where x belongs to L1 and norm x1 equal to 1. This is nothing but this less than f e1, e2, infinity and 1. So you see this left hand side is norm of f. So this implies norm f is less than equal to, so this thing is norm in L infinity. Correct? Is it okay?
Yes, sir.
But we have already proven that
Subnorm is less than norm f.
norm is less than this. So this implies norm f equal to sub I z z plus mod of f of. Correct? Okay. So we have to show that dual space of L1 is L infinity. This means we want to find a map T from L1 prime to L infinity. Okay. So this we want to prove. So define a map T, define a, take the mapping T which sends F2, F of E1, F of E2, so on. This map is linear, active, and yeah, this means this is isomorphic. And it preserves norm. Isometry. Okay. So T is N because of linear and bijective. This is isomorphism and it preserves the norm. Correct? Okay. So this is how we prove. So the same procedure we followed yesterday also while proving Rn. So their space of Rn is Rn. Do you remember this thing? यही सेम किया था हमने.
R star.
Yes, sir.
हेलो. हाँ.
Yes, sir.
ओके. सो ये पार्ट था L1 और L infinity के बीच. एक लास्ट एग्जांपल मैं करूंगा, उसके बाद बाकी आप लोग देखेंगे. कुछ और एग्जांपल्स बुक में हैं. ओके. और कुछ एक्सरसाइज में मैं दूंगा.
ओके सर.
तो अभी आपने एक नोटिस करा होगा, ये जब हम L1 चल रहे हैं तो हमारे पास L infinity आ रहा है. ठीक है, कल हमने देखा था 1/2 के लिए सॉरी 2 के लिए हमारे पास क्या आ रहा था, 2 आ रहा था, ठीक है, 2 correspond to 2, 1 correspond to infinity. So there is a relation. If I take P, it would be some Q, but there would be a relation between P and Q. What is that relation? We will see.
दोनों का इनवर्स का +1।
हाँ, कुछ बोले?
हाँ सर, जैसे 1/2 + 1/2 1 हो जा रहा था,
हाँ,
और
वन
वैसे
बाई
1/0
वन प्लस 1 बाई, अगर इन्फिनिटी को हम 0 ले
है तो 1 हो जाएगा।
तो 1 हो जा रहा है, तो 1/p + 1/q भी 1 होना चाहिए, है ना? यहाँ से ये गैस करते हैं और ये गैस ठीक है। Okay, let's see this. The dual space of LP where this P is between 1 to plus infinity is LQ. Here Q is again 1 to plus infinity and 1/p plus 1/q equal to 1. So P and Q are conjugate to each other. Okay, let's see a proof of this. So again, अभी L1 और LP में क्या डिफरेंस है? L1 और LP में केवल सिंपल सा डिफरेंस है। क्या डिफरेंस है बताइए? LP में क्या, LP में कैसे एलिमेंट होते हैं? हेलो, so if x belongs to x equal to x1, x2, xn and so on, if this belongs to LP, sorry, LP क्या हो रहा है?
xi
तो क्या क्या कंडीशन होनी चाहिए?
mod
दिस
of
मीन्स
xi
mod of xi
summation
summation
power p
1 to infinity, बताइए।
mod xi power p whole 1/p.
So this should be finite. Okay, and when we take norm xp, it is summation I1 to infinity mod xi p 1/p. Correct? So this is for future reference. Okay, let's move ahead. So similarly, but as we did in L1 case, so here also we will have a shorter basis, that E1, E2, En and so on, a shorter basis for LP is EI, where you know where EI we have seen it, this is EIK, and you know what is EIK. As done earlier, every x in LP can be written in this form, I1 to infinity, same thing where x is x1, x2 and so on. This is in LP. Okay. So as we did in first example, take f,
बाउंडेड फंक्शनल।
take a linear functional, bounded linear functional on LP. So f is linear and bounded. So you know fx will, what fx look like, this will be xi f e I I1 to infinity. Correct?
यस सर।
Okay. So far it's okay. So now we take the conjugate of P, that is Q. Let Q be the conjugate of P. This means 1 by P plus 1 by Q equal to 1, and we consider sequence. So I am writing it as xn. So xn. So I could write it as in this xn, but you know I am writing x as x1, x2 this way. So if I write it xn, you may confuse. So I'm using this notation instead of the usual notation. So here this is the sequence nx1, nx2, and so on, where n xj are given by this formula, and xi, this is defined like this. So I am writing f of ei q, f of ei 0. Okay, 1. So this is if I is equal to n and of ei is non-zero. If I is greater than n or f ei is 0, call it 0. Define 0. Okay, so what we do now, we substitute this nxi in this definition of fx. So what you get, so you are instead of x, now you will use nx. Next, so this x, so what you will get is, so instead of xi, you will get nxi. So this will be summation I 1 to infinity and xi f of ei. So, but you know what is nxi? These are from 1 to n. So for 1 to n, these are mod feiq by fei, and then from n plus 1 to infinity, this is 0. So you are getting mod feiq. Okay, so far it's okay. Is it okay?
Yes, sir.
So, but you know there is a relation between P and Q, 1 by P equal to 1 by P plus 1 by Q equal to 1. And if you solve it, you will get Q minus 1 P equal to Q. Right? So, again consider f xn. So, this is nothing but, okay, one more thing. This f belong to LP dash. One minute. What should I do now? What should I do now? Wait for a minute. Let me change it. Okay. Good. So let's do this. So what we are getting here, this fxn is summation I1 to n f of eiq, and you know f is bounded. You know f is bounded. So this means mod of f and x is less than equal to norm f, norm n x. Correct? Is it okay?
Yes, sir.
This is since f is bounded. This comes from boundedness. But you know this, that this fn is positive thing. So from double star, you see this thing is summation I 1 to n, this is positive. So here you can take this f and x. So we get this f and x is less than norm f, norm xp. So this is norm f. What is norm nxp? So this is nothing but summation I runs from 1 to infinity mod nxi whole power p, okay, p and whole power 1 by p. So this is norm f, and so by definition of nxi, so up to n these are given by this, and after that these are 0. So now the sum will reduce to summation 1 to n only, and this is mod fei. Let's write it q upon mod fei and power 1 by p. Is it correct? No, it's not correct, because there is a power p also. Let me write it correctly. So now it's okay. Is it okay? So what we did here, we just replace this nxi by this thing. Correct? Hello?
Yes, sir.
Do you get this? Do you understand?
Yes, sir.
Yes, sir.
Uh, now, now use this equality. So this is summation I 1 to n. Let's calculate it first. So both are modulus. So this is mod fei q minus 1. So this part will become this thing. Correct? And then there is a p 1 by p. You know q Q minus 1 into P equal to Q. This is Q in fact. So I'll replace it by Q. This is Q. So we get this. So this implies F and X. Let me write it again. Which was nothing but summation F E I to Q, and this is norm F and norm F summation I1 to N F E I Q 1 by P. Okay. ठीक है? Now divide by this part, both sides. So what you get F and X by summation I1 to N F E I Q 1 by P less than equal to norm F. But what is F and X? This is nothing but summation. So यहाँ पर देखो F and X is this thing. So what we get, this is I 1 to N mod F E I Q. Okay. I 1 to N mod F E I. So this is Q. एक मिनट इसको ऐसे नहीं करना let me write it first summation I1 to N F E I Q 1 by P. So this will be, so this is whole power 1, this is whole power 1 by P, and if you again solve it, you will get 1 to N F E I Q whole 1 minus 1 by P. Correct?
Yes, sir.
You know what is 1 minus 1 by P?
1 by Q.
What is 1 by Q? So this is nothing but 1 by Q. This is because 1 by P plus 1 by Q equal to 1. Okay, so far it's okay. So this means if you have the sequence Fi, F1, Fe2, Fen, okay, you have this sequence, and you know this part was true for any n. This is true for any n. This is true for any n. This means you can let limit n goes to infinity, and you may replace this n by infinity. So you are getting this. So this means when you have this sequence Fe1, Fe2, and you know its norm, its Q norm. This is bounded. This is finite. This implies Fe1, Fe2, this belongs to LQ. Correct? you do converse part. So conversely, as we did in last example, for any B in LQ, we may construct an element in LP dash. We can get a G in a G a G in LP dash. And how did we define that? In the same way we will define it here. So where Gx is summation xi beta I1 to infinity. Where x is x1, x2 and so on, this is an element in LP. Clearly G is linear. G is linear. And you have to show that G is bounded. So for that consider mod of Gx, and by linearity you get this is less than 1 to infinity mod xi beta I. Now use Holder's inequality. What does Holder's inequality say? Says this reduces to 1 by mod xi p1 by p I1 to infinity mod beta I q1 by q. This comes from Holder's inequality. So this implies mod of Gx is less than. So this part is mod BQ, part is mod XP, norm XP, correct? So from here this implies Gx, okay, sorry, G is bounded. G is bounded and norm G sorry, and mod of okay, norm of G is less than equal to where B is beta 1, beta 2, beta n. Okay. So this is what you get. This B belongs to LQ. So G was linear, G was bounded. So this means G belongs to LP1, LP dash.
Yes, sir.
So now we saw that what हाँ क्या बोले
Right.
हेलो कुछ गड़बड़ हुआ खुशबू कुछ बोले आप हेलो okay if it is fine I move ahead. So finally we have to prove that norm of f is given by q norm. So now claim the norm of f is the norm on the space LQ. So it's easy, you have seen it in previous example. So in same way we will do this 1 to infinity FEI. This is less than equal to norm XP, and this comes from Holder's inequality I1 to infinity mod FEI Q 1 by Q. So take supremum, similar thing, take supremum over all x with norm xp equal to 1. Okay, so thus we obtain norm f is less than summation 1 to infinity fei q 1 by q. So, but earlier we have already proven the other inequality. So, using these two, we can say f is norm fe1, fe2, and so on. Now, as we did in last theorem, thus we see that the mapping T from LP to LQ given by TF and so on is linear, bijective, and norm preserving. Therefore, T is symmetry and isomorphic. Thus, LP dash equal to LQ. Okay, so I'll stop here. So I have given you some exercises. Please do them. So these are, you can repeat the same process that we did here. Okay?
Yes,
Now
sir.
you drop your attendance. So if you have any doubt, you may ask.
सर
Hello?
टेस्ट कॉपीज चेक हो गई हैं
टेस्ट कॉपी चेक हो गई है.
सर मार्क्स
आप आप लोगों को मैं इंडिविजुअली मार्क्स बताऊंगा. मैं एक साथ सबके मार्क्स दूंगा तो उसमें क्या होगा कि दिक्कत होगी ना आप लोगों को. मैं इंडिविजुअली सबको उनके मार्क्स बताऊंगा.
दिक्कत क्यों?
ठीक
ओके
है.
सर
किसी के मार्क्स कम है, किसी के ज्यादा है, तो वो अच्छा नहीं है. या आप लोग चाहते हैं एक साथ बता दो तो मैं एक साथ डाल दूंगा.
नहीं सर,
यस सर
इंडिविजुअली ही
एक
बता.
हाँ बताइए. ग्रुप में मुझे भेज दीजिएगा 11 बजे के आसपास कैसे बताना है. मैं आपको सैटरडे संडे में भेज दूंगा मार्क्स, क्योंकि मुझे एक स्प्रेडशीट बनानी है, एक्सेल शीट. तो एक्सेल शीट में
Yes, sir.
आपके मार्क्स ऐड मैं दे दूंगा. ठीक है.
Okay, sir.
ओके देन बाय. सी यू ऑन फ्राइडे.
Sir, thank you, sir.